So now let's go ahead and dig into a little bit about it. To begin with, any certificate we want to sign in, we need a trusted CA. Normally, during in the enterprise world, what we do is there is a trusted CAs which are available like VeriSign, Thwart. These guys sign your certificates because they are the guys who have their own CA. But in our case, I would just go ahead and create our own trusted CA, and for that, I will create a private key for the CA, and I will just give a passphrase for this, which is test test. This is for on our own, and this is trusted uh, by us basically. And this is the same way any CA would run their own authority. Now if I have a private key, now I will have a CA, a proper CA, a password was test. Now I give here few details for the CA. Rated. Don't have organization, so I can just give test. And FQDN is the name of your machine. This have to be, I give it here. And email address is test. Yeah, so now my CA is generated and my private key generated. So once this is generated, let me generate my server keys. So for that server key, first I would generate a private key for my server. The same way I generated the CA private key. Okay, the server private key generated. Now what I do is basically I want to generate a server certificate for which I have to create a server CSR. CSR is nothing but the certificate request, certificate signing request. So which is the details of the uh, server which needs to be signed, which is sent to the CA authority, which has to be signed. Now with this, OpenSSL has few APIs which can be directly used. So these are pretty handy and pretty standard, and so you can find it across internet. So what I do here is that I have a server key here which I have given, which is basically the private key, and the output is CSR. CSR is the certificate signing request, which will be used by again OpenSSL to create a new server certificate. Now CN is host here. So host is normally a domain name, or it can be a IP also. A recommended way is domain name, but since I don't have a domain here, so I would give a IP here. So sport host equal to, what's my IP? Second. Yeah, 169.38.65. Now I run the same command. And try to generate the server CSR. Now I created my server CSR. Once I created the server CSR, I need something called the alternative names for my certificate. Like I need to have there are multiple domain names, or there are multiple IPs for which I have to the certificate is valid. So I create a configuration here, which is again similar like this. So here the IP, the DNS host is the host which I gave. IP, you give it as one loopback address because internally you want to talk. And I can give here again my same IP to be safe. 69.38.65.7. Now I give this as a CNCF name, and basically since I want to say that this is a server certificate, I pass one more parameter to this configuration, which is called server authentication, and I pass it to the configuration file. Now, once this everything is ready, I give this CSR with the ext file.cnf. So basically, what I'm telling is that please take this as a parameter for certificate signing request and generate me a final server.pem file, server.pem file. So the input, if you see, is the CSR, the CA, and the CA key. Since CA is issuing this, this is needed, and the configuration, and this enter. Since I'm using a CA, I need a passphrase for the private key of CA. Test. Yeah. So the server cert is done. Now I have created server certificates. I have created CA. Now since I want to do a mutual trust, I need to generate a client certificate. To generate a client certificate the same way, the client and server is just our convention, but as a approach or from certificate perspective, the keys remain same. So I generate a private key for the client, and then again the same thing, I have to generate a CSR for the client, but in this case the common name is a client since it's not associated with the some host name, so that's why it's cn is equal to client, specifies it's a client. Again, the extended usage for this cf file basically is this client auth is, it's a client authentication as a key usage. And now I tell my CA, please sign this client uh, with the given CSR and this configuration. It's the same at the end for server, but instead it's just a client CSR and the files with the client extended key usage. Test. Yeah, now my client certificates are generated, my server certificates are generated. But now let's, to be safe, let's remove the all the files. So I remove all these files, and now what I do is, since the private keys have to be only accessed by the owner, so I give the access only to owner. So if you see here, anything which is suffixed with the key is basically a private key. And I just say anything which is suffixed with the key is a private key. And now what I do is, let's make the servers world readable -p0440, not 0444, because it should be accessible by everyone. And the ca.pem server cert cert. Now I change the modes of these certificates, that it's a world accessible, but it's only readable. So now what I do is that, since these certificates are what to say, available on the server, and the client can be generated on the server or on the client machine, so it doesn't matter. Now what I do is, I move these certificates, for example, let's do that later. Now I will just copy my client certificates to my Docker folder. So this, I want to make sure that all my client certificates are already there in my client before I start using it. So I can try here. I have a template already copied here. Oh, my username. Okay, so basically what I'm copying is CSCert ca.pem, which is basically the CA certificate, and cert is the client certificate, key is the client private certificate or private key. So, and that's my host. So now my ca.pem, sub.pem and key.pem basically are copied into the docker folder. So which means that Docker by default picks it up. You don't have to tell explicitly with environmental variables, please pick it from here. Now, so it is done with the certificate generation. Now the next step is include this into the um, systemd. In the previous session, I explained you how the systemd is configured for Docker, and here I just stop Docker. So I stop Docker. Now I stopped. So now what I do is I want to override the configuration with the um, certificate. So what I do is I just say sudo systemctl edit docker. So this way what I do is I am trying to overwrite a systemctl file in the etc/etc/systemd slash system docker.service, which will make sure that I want to run my own executable as a start. So I just copy this, it's already there with me. I can tell you what I'm doing actually. In the exec start, I'm overriding the old file descriptor way of executing it, and I am uh, executing it via Unix sock as well as 2376 port. And also what I'm doing here is I'm passing the CA certificate, the server certificate, and the server private key. So this way I'm overriding the old to nothing and just overriding the new one here. So saved here. So one way of the good approach of doing this is that you don't have to do a system restart or the daemon reload basically, since systemctl is already taking care of it. And then what I do is, since I mentioned the path as etc docker certs where I moved it, so let me move my certificates c.pem key.pem server cert key.pem to etc. So I moved my CA and server keys to the etc docker certs, which is needed. Now what I do is, let's say sudo systemctl start. So sudo. So if you see here, my Docker is started and now it is run with the new command with the docker.sock with the Unix socket and the TCP 2376. And if you see here, I have a drop in here. So this is basically I'm overriding, which is from the lib systemd docker service to my own custom configuration, which is override.conf. So this is the way I'm in the systemd overriding the configurations. Yeah, so this is done with the installation of Docker with the TLS. Now the next thing is, let's talk the client with the server which is installed. So that I will show in next session, because I'll explain you everything what's happening under the hood. Thank you.